Hi, everybody. This series of videos is about the key features of a quadratic function. The graph of a quadratic function is called a parabola. So to the right of the screen, what you see is a parabola with all the parts labeled. But in this particular video, we are going to first talk about concavity and end behavior. In the next series of the videos, you will learn about line of symmetry, or what we call axis of symmetry. You will also learn about the vertex, minimum, maximum, the domain, range, the interval of increasing or decreasing, the x-intercepts, and the y-intercepts. So let's go ahead and get started talking about concavity. Before we get started, really good with that, I want to go ahead and make sure you understand how, if our graph were to continue on in all directions, what would happen. So let's look at the x-axis. This is the x-axis. If our x-axis were to continue on forever in both directions, on the right side, it would go off to positive infinity because the numbers are getting more positive and more positive. On the left side, it would go off to negative infinity because the numbers are getting more negative and more negative. Now let's look at our y-axis. If our y-axis were to continue on forever and ever in both directions, let's go to the top first. Our y-axis, if it was continued upward on forever and ever, it would go off to positive infinity because the y values upward are getting more positive and more positive. If it were to continue on downward, our y values would go off to negative infinity because the numbers are getting more negative and more negative. Now that we talk about that, we can now talk about concavity. The concavity of this graph is the shape of the U, the direction of the U. So a parabola has a U shape, and in our case, it looks like it's going upward. So our graph is concaved upward. Now we're ready to talk about end behaviors. With end behaviors, we're talking about what's happening on the left-hand side and what's happening on the right-hand side. So on the left-hand side, the way we say left-hand side mathematically is by saying as x approaches negative infinity. Now the question is, what is the y values doing on the left-hand side as x approaches negative infinity? So at the ends, our y are approaching positive infinity on the right-hand side. It is approaching positive infinity. If this graph were to continue on forever and evermore, it would be going towards positive infinity. Now let's talk about what's happening on the right-hand side. The way we say right-hand side mathematically is as x approaches positive infinity. What are the y coordinates doing at the end as x approaches positive infinity? So if we go to the right-hand side over here, if this graph were to continue on forever and ever in this direction, it would also go off to positive infinity at the ends. And that's how you determine concavity. Let's take a look at what's happening to this graph. Like we said before, on the left side is negative infinity for the x-axis. The right side is positive infinity for the x-axis. Upward is positive infinity for the y-axis. Downward is negative infinity for the y-axis. Now let's look at the concavity. The concavity of the graph, if we trace it, again, the parabola is a U-shaped graph, it looks like the U is facing downward. So the concavity of the graph is concave downward. Now we're ready to talk about the end behavior. So we look at on the left-hand side and on the right-hand side what's happening with the end behavior. On the left-hand side, we say left-hand side by saying as x approaches negative infinity. What is y doing? So we see here that the y at the ends are going off to negative infinity. If this graph were to continue on forever and ever, it would go off to negative infinity. So y approaches negative infinity on the left-hand side. Now let's look at the right side. As x approaches positive infinity is how we say the right side. As x approaches positive infinity, what are our y coordinates doing at the end? So at the end, our y coordinate is actually going off to negative infinity again. So if this were to continue on forever and ever, it would go off to negative infinity. And that is how we determine concavity and end behavior. So let's take a look at this graph. Determine the concavity and the end behavior of this graph. Go ahead and pause the video and attempt it on your own. So hopefully you tried this on your own, and now you can see that this graph is concaved upward. And on the left side, as x approaches negative infinity, y approaches positive infinity. And on the right side, as x approaches positive infinity, y also approaches positive infinity. So now let's take a look at the next graph. I want you to go ahead and attempt this one on your own as well, and pause the video. For this graph, we see that the graph is concave downward. As x approaches negative infinity on the left-hand side, y approaches negative infinity. As x approaches positive infinity, again, the right-hand side, y approaches negative infinity. And so that's how we determine concavity. Look out for the next video.